Let's look at some syntax for the Jack language. It looks very similar to other programming languages. So we can see common themes, white space / comments, examples of those, and where they have the three types of comments we have. We've seen the various keywords in Jack: class, function, var, void, let, do. Also have int, the types, void, those things. So we have program components, primitive components, variables, etc., etc. We have different symbols. All right, these are going to be specific characters and things that have meaning for the language. So curly braces, which indicate that we are in a block of function that's related to each other. Parentheses can indicate that we are passing variables. We close lines with semicolons, and then we have things like array access with square brackets. Commas, of course, are going to be used for separating variables, and then we also have the operators, and, or, multiplication, etc. Constants. So we have some constants like 0, constants like 1, but we also have constants that are string literals. So for instance, the string, how many numbers? Enter a number. Those are examples of just constants. We program those into our program. Those aren't going to change. They're just a literal that gets then translated. Also in this, I don't think we have examples that are Boolean constants, such as true or false, and then null is a constant in the language, which represents a null reference. Yes, and by the way, integers can be negative numbers as well. Then we also have then identifiers. So these are different from what we talked about. These are going to be things like variable names, function names, class names. These are symbols that take on meaning for the language that can change. So much like in Project 8, when we were looking at VM variables, that sort of thing, these are arbitrarily sequence of letters and digits. The first character must be a letter or an underscore. We cannot start with a number because that can mess up some of our text processing. And our language is case sensitive, so X and capital X are going to be treated differently. All right. The data types we have. So here are some examples. We have the primitive types of integer. That's a 2's complement integer in the range 0 to, did I just say that's negative? I thought it just said we could have a negative number. I forgot. Let me explain. We can have negative numbers, but that really is an operator, which will then compute the negate or negative version of an integer. So we can only have integer constants. That's semantics, but not negative numbers. So yeah, we have integers. Doesn't matter. We have booleans, true or false. And we have characters. Strings and characters are a little bit interesting in the Jack language. Characters are going to be an integer. Got that? An integer representing a character, not the character itself. That we'll see. We also have some class types. We have string.array, and we also have other items that we can define ourselves, such as fraction and a list, which we've seen with. This is an important slide. You'll want to see this. This is the hack character set, and it has all the integers that we will need to represent the various encodings. So for instance, base is the integer 32. This is where I was talking about characters are kind of weird. So let's say we have a character C and a string. String is a data type provided by the system. We can easily assign the letter capital A to C by saying let C equal 65. Problem. But if we say let C equal the literal constant A, it will not work. That's not supported. However, of course, there are ways to get around it. We can create a string that's assigned the single letter capital A and then say, well, let C equals the string dot character at location 0. And that will work. That will assign the initial character of that string to be the variable. All right. An integer can be assigned to reference variables. In that case, it's treated as memory address. So if we see a var array created ARR, so we create an array reference called ARR, and we're less than equal to 5,000. That's okay. We can say let our array bracket 100 be equal to 17. That works. So an object can be converted to an array. Also, just vice versa. You'll see that let array equal 5,000. We didn't create a new array. We just simply assign that the integer, and that array bracket we just went off into memory location 5017 access. All All right, so there we have an array ARR. We said create a new array of length 2. Then we said let array 0 equal 2, let array 1 equal 5. So we just assign the values. Now we can do something very interesting. Let's create a new fraction called x. We already seen how this works. We know in memory that somewhere in memory we have the reference to a fraction. It's got the numerator and then the denominator next to it. So we could say let x, this new fraction reference, be assigned the same value as ARR. And that really means that we're taking this pointer to array. We're then saying here, x, you have that, but x is a pointer to a fraction. But then we can now do things like x.print. Well, that's going to go into the fraction class and call print. And what it's going to do is print 2 over 5 because every object is just a pointer to somewhere in memory. So the fraction has two fields that are both integers. We put 2 and 5 next to each other. Now, if we treat that as a fraction, we can then treat that as a numerator and a denominator. It's kind of one of these really sneaky magic things. And of course, in languages like C, you can kind of do this and shoot yourself in the foot. And Jack also gives you the tools and says, here, shoot yourself in the foot if you want. All right, lastly, or like a second last, is classes. The class in Jack is the basic compilation unit. So each class foo is stored in a separate file called foo.jack. And then the class's first character must be an uppercase letter. That's how it is. So each class is going to have field variable declarations, going to have static variable declarations, and subroutine. The field and static variables must be in front of or on top of the constructors, methods, and functions. So field variables are things that are accessible to just that instance of the class. So in Python, that might be like a self dot variable. In Jack, we have this, and that we're referencing just kind of our self. Static variables are more like class-wide variables that is shared among all instances of the classes. If one class instance modifies a static variable, all instances can access that and see the updates. So we have some utility classes. These are kind of like standard libraries that the system provides. So we have the math class API, and it provides several useful functions such as absolute value, multiply, divide, min, max, and square root. These are very useful because we do not have these items in hardware. We only have add and subtract, but we can then implement multiply in software. Do be warned that these will all return the integer parts. We have no floating point implementation of Jack, or in Jack, so everything is integer math. All right, these are called utility functions or static methods because they're really not creating, we don't create instances. There's no constructor. So we think of this as a library of services we can use. So classes that represent entities or the objects, those are going to be things like fraction, list, string, some of the stuff we've seen. So that means we need to have one method. That's a method is going to be something that operates kind of on itself. And when we have some different helper functions, maybe might also support that, similar to static variables. So the best practices don't mix library functionality, which are just kind of generic helper functions that can be accessed by many things, with object representation of the same class. If you can, start separating kind of that stuff out. Have a class be kind of one conceptual unit that is all related very much to each other. So this is a bad example of what I talked about. I've already shown you this, and actually was the bad example, but I'll show you why. This is our fraction class. We created a new fraction with numerators and denominators. We had the function to reduce. But if you look at this GCD, that was just a helper function, kind of a generic way to calculate a greatest common denominator of the two numbers. And really, what we should have done there was take that out, put that into a math class, provide the greatest common denominator, and then use that instead of putting it into our fraction class. That's kind of mixing the idea about things needed for a fraction with generic math libraries. And just starting to do things like that will help you kind of break things apart. That's an example of when we compile Jack. The basic compilation unit is a class. Now, an application or program is a collection of many Jack files or classes, and then one of those must be called main. And then when we run main.main, that's where we start running code. What will happen is that when we start compiling a program, we'll compile multiple Jack files together into one final machine code file, the program that we run on a computer. So the OS provides some high-level services, and it's supposed to serve as an interface between your program and then the host hardware. So things like integers are there, but also things like keyboard and how we can access reading information from the keyboard or printing strings. That's a way that we can kind of unify all that together. Think of it like a standard library. That's probably the best way. There's an API. I think a PDF is posted in the Nantu Tetris files, but we have math, string, array. These are all helper functions. Output, that's how we can print things to the screen. That's more like printing items, versus the screen class, which has things like draw pixel, draw circles, draw rectangle, or the graphics helper functions. We also have keyboard, memory, and then sys. Sys really doesn't do much, provide halt, but also wait if you want to kind of add in a delay. Check the website in book for more details. All right, I'm going to go ahead and stop there because it's getting a little long, and then we'll come back with the last item.